Well, I'm so happy to welcome Tim O'Reilly, the CEO and chairman of O'Reilly Media, to the Look Back podcast. And we have plenty to look back on, but we're also going to spend some time looking forward as there's so much going on. And Tim is really crystallized a lot of views on AI and its impact on technology, its impact on society. I've read a lot of his work lately. Tim, you're also doing a lot on the investment side with AlphaTech and Ventures. But as I welcome you to the podcast, I mentioned, and we were joking earlier about how we shared a lot of similar time working in the media space and working at the tech companies that I worked for, and you, of course, started O'Reilly Media. So welcome to the podcast.
All right. Well, great to be here.
Yeah, I appreciate it. So why don't we start back with, some 40 plus years ago, when all this tech B2B content and people were starting things like PC Magazine and CRN, and you jumped in looking at really what needed to be happening around the content world, around training and learning. It's interesting because we live in a time in technology. We know the only thing constant is change. So
Yeah.
it obviously has proven to be a hotbed of a topic for you.
Yeah, I think what I would say is both looking backwards and looking forwards, I will kind of identify the same kinds of inflection points because I entered the industry at an inflection point, and it was in some ways it was contemporaneous with the microcomputer revolution, that was represented by Steve Jobs and Bill Gates, but of a slightly different flavor because I came into it around, I was originally a technical writer and I was writing proprietary manuals for proprietary companies. And I recognized my first piece of public advocacy was in 1984, where I wrote an article called Documentation and the Future of Unix.
There you go.
I think it was from a newspaper called Mass High Tech. I was living in Massachusetts at the time.
Awesome.
And it was really about how the PC was becoming this standardized, this sort of democratizing architecture for computing. It would come out, IBM, you had to be, even in with the mini computer era, computers were something that were in a computer room, and there was a priesthood that had access to them, and it was limited. And suddenly it was the era of a computer on every desk and in every home. But there was another version of this that was happening with Unix, which was all of these big computers started running the same, effectively what we later called open source operating system. And that original open source version of Unix was coming from Berkeley, University of California at Berkeley, but it was derived from System 5, which is a proprietary operating system that was, created at Bell Labs. But it was interesting because I recognized that there was something happening here in the way of the standardization of the software layer. And I fell in love with Unix because it had several things about it were so foundational to what really became the internet and the world that we live today. The first of these was that it had what I later called an architecture of participation. And what I meant by that was really crystallized probably 15 years later by Linus Torvalds in a conversation where he said, we were talking about open source and all the debates about the licenses, and he said, I couldn't have written a new kernel for Windows even if I had all the source code. The architecture just wouldn't support it.
Right.
And and that was why, if you want to see this, go read there's a Wikipedia entry about the Unix, a book called The Unix Programming Environment by Kernahan and Pike. I wrote the original version of that Wikipedia entry because it summarizes what I love so much about Unix.
Yeah.
This idea of cooperating programs that all use the same language. And if that sounds familiar, that's also a description of the World Wide Web.
It does.
And so I fell in love with that. And there was also this idea of a simple progression. On both the text processing side and on the programming side, you had this notion of a command line that also turned into a programming language. And it was a lot like babies. They can talk with few words, and then they eventually put together sentences and paragraphs. And in a similar way, the same commands that you would type on this command line interface could be put into a shell script, or you could be using regular expressions and doing complex edits, in the text editor, or you could write programs, effectively programs in what's called a stream editor called sed, and then awk, and then eventually Perl, and then eventually all these other programming languages. So there was this continuum from simple speech to complex speech. And that planted in me the idea that in some sense, the fundamental idea of programming is speech with computers. And that over the decades, that speech has become easier and easier as computers become closer to humans and to understanding human speech. So if you think about the very early computers, you literally wired up a circuit. And then you put in a program in bits, and they got to the point where they could flick little switches on the front panel, and then maybe with punch cards. And then you start getting higher level languages that would produce, or you would have first assembly language, which was slightly higher than just the binary code. And then you would have compilers that produced binary code. And then you had interpreters that produced binary code. So you get up to the PC and you have this explosion of access to computers when people can speak this simple language called BASIC and create applications. And the next big wave was with the World Wide Web. And I was so taken with the web. We published about the web when there were only 200 websites. We published a book in 1992 called The Whole Internet User's Guide and Catalog. It went on to sell over 1 million copies. But the thing that was most important about it was at the very end, we added a chapter about this new thing called the World Wide Web. And it was the way the web was introduced to the world.
A little hat tip to Stuart Brand and a few of the
other. Yeah, it was a hat tip to Stuart. I asked him if it was okay, and he said yes. Stuart was one of my idols. The very first piece of writing I'd ever submitted to a magazine was to his Coevolution Quarterly when I was like
great holders
16 years old or something like that. Yeah. Anyway, so this idea that really sort of obsessed me was that the web, was this new paradigm in which we could basically you could embed commands to a computer into a human readable document. And that was a transformative interface, even more than the GUI. Because, if you look at, say, Microsoft Word, or something like that, you would have little bits of human language embedded as menus, as prompts, as, dialog boxes. And suddenly, with the web, you're over a continental divide where you're on the other side, you're in human readable documents into which you've embedded little bits of program. You click on some links and they just take you to another document, but some of them invoke an action, and that invention of what was originally called the Common Gateway Interface by Rob McCool, was in many ways as important as the original hypertext languages of Tim Berners-Lee. Anyway, but the point is, computers suddenly were much closer to humans. And what happened? More people doing this. So now here we are with AI. And suddenly, isn't that the third iteration of this, or third or fourth or fifth, however you want to count, this new iteration in which now we can just talk to them. And they can.
We're our agentic.
That's right, and we're and some people are like saying, "Oh my gosh, this is the end of programming." I'm going, no, everything has been the end of programming. It's like each time it's gotten easier. There's a bunch of skills that have become not entirely obsolete. There's still certain circumstances when you want to debug with an oscilloscope if you're doing embedded programming or something, but most people don't have to do that anymore. That was table stakes back in the day. And now, you can't even debug, and like back when I was first programming, I was like, you're debugging, you're stepping through a program and going, oh, this is exactly where it failed. You can't do that anymore. But that doesn't mean it's the end of programming. It's just the new beginning. And so
That's a great way to look at it. But let me ask you on that point, when we started all this stuff back in the 80s, early 80s, we were still talking about AI.
Yeah,
it was still a known topic. Did you expect it to raise its head, or have you been watching it peeking out ever so slowly until we get to, the last couple of years here.
Well, I think a couple of quotes come to mind. One is Bill Gates. We always overestimate what can be done in a year and underestimate what can be done in 10 years. And the other is from Alvin Toffler. He said the future always comes too fast and in the wrong order. you know, uh, and we're always taken by
That's
surprise.
a future shock, right?
Yeah, we're always taken by surprise. And I do think you can prepare yourself, but as that great quote from I believe Louis Pasteur, fortune favors the prepared mind. And the prepared mind is one that gets that there are periodic breakthroughs, that it's not necessarily continuous. And
Would that be Sam Altman today?
no, not no. Actually, I have to say I'm probably a little contrarian here, although less so now that DeepSeek has come along.
Okay.
I've always said from the first moment when everybody's like, "Oh my God, this is the next Google," I'm like, "No, it's the next AOL." Or
Okay.
maybe it's the next.
But you're going back to open source or democratizing. So please expand on that.
Yeah, I mean, I think what's happening now is actually we're in the with DeepSeek is when the real AI era has begun. The one that's gonna be truly consequential. Well, let me put it this way: if you again, I look at the history when Google published the Transformers paper and released BERT as open source. I said, oh my gosh, they've just done to themselves what IBM did with the release of the specs for the PC. They don't know it yet, but it's going to bite them in the ass. Because basically they gave away their secret sauce, not understanding that they had done so. The PC, it wasn't open source in any way, but literally IBM was like, hey, we got to compete in this market. Let's design this standard computer made of off-the-shelf parts, which was pretty revolutionary. And then they went, well, we need to have a bunch of people make driver devices peripherals that we don't make, so we'll publish the specs. And then people started basically making them, and you had this real race where then hardware, which had been the source of their monopoly, became a commodity.
Yeah.
Something else became valuable. Many years later, after I first started talking about this as a seminal moment, Clay Christensen and I had this we were both speaking at the Open Source Business Conference I think it was in 2004. And he had just published a piece where he had this fabulous, and he gave a talk about this. It was about what he called the law of conservation of attractive profits. And I was just starting to write about what I was calling Web 2.0 with exactly the same narrative, which is something has become a commodity and something else has become valuable. And I was sort of saying, look, open source and the open standards of the internet are commoditizing this world of proprietary software that we were taking for granted. And something new will be valuable. It's going to be collective intelligence and big data. And I said data is the new intel inside, all these things that I talked about in the Web 2.0 paper. But it was really coming from this deep historical analogy. And then I saw another deep historical analogy here with as I say, at this moment when the Transformers paper came out and BERT, I suddenly went, oh, we can now search our content and build services against our content as well as Google can. It used to be, when you used to do search with something like Solr, it was like playing whack-a-mole, and if you didn't have a big team, you didn't have enough people with hammers to whack all the moles, it was pretty hard, and suddenly it became much, much easier. And I went, oh, this is going to be interesting. I didn't expect ChatGPT, but I knew the industry had just been completely destabilized. And the thing that, again, that helps you kind of see your way through these big transitions is and actually Jeff Bezos talked about this once. He said, everybody asks what's going to change. And he said, a more interesting question is what's not going to change.
Yeah.
Now, in his particular example, he was talking about people are still going to want faster, they're still going to want cheaper. But for me, I'm maybe a little more of an egghead. So I say, well, one of the things that is not going to change is that you get more innovation in periods when the barriers to entry are low, when the market is destabilized, where newcomers can come in and invent the future. And because of that, I've really been very skeptical of the state of Silicon Valley for the last 15 years. What's wrong with Silicon Valley is it went from a model in which open innovation was the winner, to capital was the winner. So if you think about Uber, well, actually, a really interesting comparison. The guy who really invented what we now think of as Uber and Lyft was a guy named Sunil Paul, who actually patented some of those ideas in 2000, 10 years before. He was way too early, 10 years before Uber and Lyft.
What do I remember that name, though, from Sunil?
Oh, he had a number of companies.
Yeah, okay.
And he raised $35 million, which coincidentally is all that it took for Google to raise.
Yeah.
But in a very, very different venture capital environment, suddenly there was billions of dollars available post the 2009 financial crash, and suddenly there was so little, the money was practically free, and suddenly VCs realized that they could buy premature monopolies. And so only after Uber and Lyft went public, so they wiped out everybody else, and only after they went public did we really begin the search for true product market fit. Like, what's the right price? What's the right business model? How do we pay the drivers right? And of course, the product got much more expensive. And we would have had a much richer period of experimentation if this had been, low barriers to entry. So along comes AI, and I wrote a piece several years ago called AI Has an Uber Problem, because it's like the VCs bought the winner rather than the market discovering the winner. And so that's why I say that OpenAI looks a lot more like AOL or maybe Netscape at the beginning of the web.
Yeah.
So they're playing by the old rules. They're trying to be the old generation, and now along comes a true disruptor.
But does that true disruptor then become the standard bearer, or are they just the enabling?
They're the enabler, and I think that's the important thing. Again, if you at least for me, this narrative that's been sort of my life's work in some ways.
Right.
This narrative explains a lot, because it tells me, for example, even when ChatGPT was coming on, like, oh my gosh, I'm going, no, it's not the final end state, because it looks too much like the past. It looks like the end state of the web, right, rather than the beginning state of the new thing, because it has all the characteristics where we're going to just sort of step into the shoes of Google. And that's exactly what happened with Netscape. We're going to step into the shoes of Microsoft. Yeah. And with the PC transition, it was like, right, HP and Dell and all these companies. Well, we're going to build these PCs, and we're going to step into the shoes of IBM, right?
Well, at that point, NVIDIA didn't step into the shoes of Intel. They created their own shoes, right? But it'll have to be another time. I really appreciate it.
Do it again another time. All right. Thanks a lot.
Thank you so much.
Right. Okay. Bye-bye.